Welcome to Transforming Energy, the NREL podcast, brought to you by the U.S. Department of Energy's National Renewable Energy Laboratory. We're bringing you the latest in clean energy research from the lab. It's Wednesday, February 21st. I'm Karen Jerriman.
And I'm Taylor Mankel.
Now boarding for Sustainable Flight 477 with service from Golden, Colorado.
Wait, Karen, we're going on a trip here?
Yeah.
I didn't pack my neck pillow or, more importantly, road trip snacks.
Oh, don't worry, Taylor. I always have snacks in my bag. Always. But more importantly, don't worry because we're not going far. Really, anywhere, actually. This first story is all about sustainable aviation fuel, and we're focusing on the researchers who are firmly on the ground in Colorado.
Whew, and I'm glad to hear jet fuel changes are finally taking flight. Not much has changed since petroleum jet fuel first became widely used in the 1950s.
Always for a good pun with you. I love it.
Better believe it.
Petroleum jet fuel has a long record of safety, performance, and ease of use. But at the same time, it's bad for the planet. And as air travel continues to grow, carbon dioxide emissions are expected to double by 2050 if we don't do something.
Which is why the adoption of sustainable aviation fuel, or SAF, is so important. SAF is an energy-dense, renewable fuel seen as essential for decarbonizing flight, and along with it, needing to be fully compatible with existing jet engines. We need to prove the fuel is just as safe and reliable as the old stuff.
In fact, the federal government has a goal to increase SAF production to 3 billion gallons per year by the year 2030. Just for some comparison there, that's about as much liquid as is in more than 9,000 Olympic-sized swimming pools. NREL senior researcher fellow Robert McCormick explained the challenge the aviation industry faces.
So this idea of designing a new jet fuel is like a completely new concept to the aviation industry. They've never designed a new jet fuel before, and they've always had exactly the same fuel. And really, unlike gasoline and diesel fuel, which have changed quite a lot since the 1950s in response to environmental regulations and engine efficiency requirements, jet fuel hasn't changed that much. So essentially, they've designed the engines around this one fuel.
That's a steep learning curve for an industry that has built its fleet around a fuel that hasn't changed in 70 years.
But the aviation industry has help. Multiple teams at NREL are working together to develop an ultra-detailed simulation of SAF combustion. Picture it, a virtual jet engine that's powered by supercomputers to predict how SAF will perform during flight and what adjustments we need to make to maximize its safety and performance.
This research could help the aviation industry avoid costly surprises and reveal new possibilities for jet fuel chemistry that could help planes fly farther, run cleaner, and perform better than ever before.
Which would be amazing, right? But back up a second for me, friend there. Surprises. Tell me a little bit more about what surprises we're talking about here.
Yeah. So let's dive into the process of getting approval to use a new SAF formula. ASTM International is an organization that sets global jet fuel standards. These standards ensure jet fuel, no matter how it's made, can be dropped into existing airplanes, no matter if they're being fueled in Denver, Dubai, or Dublin.
Okay, I gotcha. So any new liquid fuel must meet a set of safety, performance, and operability standards and must be functionally identical to petroleum jet fuel. Is that right?
Exactly right, Karen. And proving it meets those standards means using thousands of gallons of SAF to pass the qualification tests.
Okay, so that's where those computer simulations must come into play. NREL researchers in both the computational science area and fuels and combustion focus teamed up to develop modeling tools that can simulate aircraft engine combustors. NREL's Shashank Yelapantula is on the team that built an open-source combustion simulation. It's based on a NASA jet engine combustor.
Engine tests drink a lot of fuel. You need hundreds of thousands of gallons of fuel. And it's expensive. We will eventually be doing engine testing, but simulations in the short term can provide information that could directly help you tune the process to get better fuels.
We're testing without wasting. It's much more efficient all the way around.
And we love that. Currently, ASTM International requires SAFs, and remember, that stands for Sustainable Aviation Fuels, just in case anyone forgot, requires SAFs to be blended with conventional jet fuel. But to really reduce carbon emissions, we'd need to have 100% sustainable fuel.
The NREL team is analyzing a SAF that's been approved for commercial use by ASTM since 2011 and is actually already in use in California, but only when being blended 50% with conventional jet fuel.
First, NREL's fuel properties team is using a bunch of highly specialized equipment in our labs to expose this SAF to all kinds of conditions and gather data on how it responds, how fast it burns, pollutants it releases, viscosity at different temperatures, things like that. And instead of those thousands of gallons needed for engine testing we mentioned earlier, they're using only milliliters to accomplish this.
Then Yelepantula will pull the information into NREL's simulations.
This could act as a service. Do newer fuel manufacturers or the smaller startups who have some innovative idea to convert, let's say, woody biomass to jet fuel? And they don't have the resources to do all of this research, but here we are creating an open source platform that takes in the information from the fuel production side, measures the fuel properties in our measurement capability here, simulates that, takes the fuel properties and simulates a combustor, an aircraft engine combustor, and looks at combustor performance and goes back and provides that information back to the fuel production team on how they could optimize and how they can improve their process. And this whole research ecosystem can act as a service and we're making all of this open source so that somebody who's a new fuel producer can just mirror this process and improve their own production pathways.
We're getting closer to cleaner skies with the help of supercomputers and super researchers. And on a somewhat related note, too, we wanted to point out Yelepantula was very recently awarded for his research and named a 2024 American Institute of Aeronautics and Astronautics Associate Fellow. The recognition honors contributions to the arts, sciences, or technology of aeronautics or astronautics.
Yelepantula has more than 30 scientific publications and 3 patents, so to say he's impacted the industry is an understatement.
NREL's different research areas sometimes team up to achieve a common goal, but NREL itself also sometimes teams up with other national laboratories. Do you know that?
Yes, and that's exactly what we did to conduct a new analysis on geothermal heat pump installation. You may have also heard this referred to as ground source heat pumps or GeoExchange.
Yeah, so a quick overview on geothermal heat pumps. They tap into the relatively constant temperature of the Earth just below the ground to heat and cool. It's an efficient way to heat and cool homes, businesses, college campuses, downtown districts, entire housing developments. You get the picture here. It could go on.
Yes, and not only that, but geothermal heat pumps can be used in all climates and rural or urban environments. They can be installed during new construction or added as part of renovations to existing infrastructure.
Very cool. So to study the clean energy potential of the heat pumps, NREL joined forces with Oak Ridge National Laboratory, which is based in Tennessee. Together, the two labs found that when coupled with improvements on building walls, roofs, anything that separates the inside and outside of a building, basically, by coupling those improvements and installing geothermal heat pumps in and around 70% of U.S. buildings could save as much as, ready for this, 593 terawatt hours of electricity generation, or in other words, about 15% of the country's current annual electricity demand annually.
That's huge. There would be less need for generation capacity, storage, and transmission compared to other energy pathways.
So not only could widespread adoption of geothermal heat pumps help decarbonize the building sector, but the analysis also suggests that if we combine this adoption with other efficiency measures, like building weatherization, it'll benefit energy users and improve the electricity grid.
This also means creating more jobs for Americans. We'll need a workforce to install and maintain these systems.
Energy savings, more jobs, a resilient electricity grid. Geothermal heat pumps could provide benefits to not just those who install them, but to all electricity consumers.
Do I say it?
You say it.
Geothermal heat pumps could help our clean energy goals move full steam ahead.
You're such a pun master. I love it.
Oh, geothermal energy. It's so hot right now, Karen. To wrap up this episode, we have one of our special correspondents in studio with us.
February is Black History Month, and today we are spotlighting NREL's Black Employee Resource Group, known as the Black ERG.
With us today is Natalea Small, the communications representative for all the employee-led groups at NREL. Our longtime listeners may remember her from our Hispanic Heritage Month segment last fall, where she introduced us to members of NREL's Hispanic and Latinx Alliance. Natalea, happy to have you back on the show.
Thanks so much for having me today. So happy to be in the studio with you both today.
All right, we're glad to have you. So tell us more about who we're going to hear from today.
Of course. So Kamaira Coney and Sika Gajanku are NREL researchers, and they co-lead NREL's Black ERG. Every February and throughout the year, the Black ERG hosts events here at NREL and in the Denver metro area to showcase the amazing work we do here at the laboratory. I'm going to hand the mic over to Sika and Kamaira to share about their roles at the lab and how the Black ERG is working to make a positive impact, both here at NREL and in the local community.
Hello, my name is Kamaira Coney.
And I am Sika Gajanku. Kamaira and I are both researchers at NREL, and together we co-lead NREL's Black Employee Resource Group, or the Black ERG for short.
Yeah, we've been co-leading the Black ERG since last summer, but we've both been at the lab for almost 5 years now. I've always had the passion to make sure we are taking care of our environment and people. The more harm we cause our environment, the more harm we cause ourselves. My research focuses on community engagement, energy equity within solar adoption, buildings, and mobility. I have a huge passion for figuring out how we can bridge the gap between community challenges and NREL's tools and capabilities.
And I use my engineering and policy background to research floating solar systems, workforce impacts of the clean energy transition, renewable energy integration, and more recently, working directly with cities and communities in the U.S. transitioning to clean energy. It's been great getting to work with both domestic and international partners, whether it's cities, different nonprofits, community-based organizations, and also internationally working with different government agencies, all focused on how to decarbonize their various energy systems. So thinking about the ERG, the Black ERG launched in February 2020, and we've been steadily growing ever since. Our mission is to be a strategic partner with NREL to promote a culture of inclusion and diversity through continual learning. We're focused on developing and supporting a vibrant community for NRELians that identify as Black and/or of African descent. In this Black History Month, we're focused on Black lives in the clean energy transition. Energy systems permeate every aspect of life. So events this month and throughout the year will try to deepen our collective understanding of how NREL's work connects to broader lived experiences.
Yeah, absolutely. I'm very excited for the events that we have planned for this month and throughout the year. So for the last 2 or 3 years, NREL has been leading the effort in energy equity and environmental justice. So it's really important for us to understand Black lives and how this climate crisis impacts various communities. So within the Black ERG, our activities focus on retention, recruitment, and community engagement. For retention, this means building a welcoming community for Black NRELians, interns, graduate students, full-time staff, that supports employee satisfaction and long-term talent retention. Our group consists of researchers, finance folks, graphic designers, HR, communication specialists, whose work spans early-stage research through demonstration. Their work might focus on bioenergy, building sciences, circular economy, computer science, energy justice, and workforce development.
Right now, though, only 2% of NREL identifies as Black and/or of African descent. So we're also very much focused on supporting greater representation and recruitment of Black people at the lab. And we do this through partnerships with other NREL groups and support of broader NREL initiatives.
Yes, and also we are trying to do this community engagement beyond our NREL campuses. That way we can expand and build upon NREL's relationships with our local communities through mentoring, K-12 programming, and in-person community events. As a matter of fact, last year around this time, we had an amazing community event at the Aurora Mall. We had an opportunity to collaborate with other folks in the area and just get people to know who NREL was and get excited about potential researching or science jobs. So with that, I'm going to wish everybody a happy Black History Month. We encourage you to check out nrel.gov for resources and be on the lookout for other events throughout the year.
Happy Black History Month.
From NREL's Black Employee Resource Group.
Amazing. Thanks so much to Natalea, Kamira, and Sika. Listeners, we'll be back in 2 weeks with more news from NREL.
This episode was adapted from NREL news articles from January 2024, written by Eric F. Ringel, Justin Doherty, and Kelly MacGregor. Special thanks to correspondent Natalea Small. The theme music is written and performed by Ted Vaca, and episode music by Chuck Kernick, Jim Riley, and Mark Sanseverino of Drift BC. This podcast is produced by NREL's Communications Office and recorded at the National Renewable Energy Laboratory in Colorado. We express our gratitude and acknowledge that the land we are on is the traditional and ancestral homelands of the Arapaho, Cheyenne, and Ute peoples. We recognize and pay respect to the indigenous peoples of our past, present, and future, and are grateful to those who have been and continue to be stewards of this land.